All right, discrete math. You know what? We're back at it. In this video, we're going to talk about a string over x. Now, string is a word used in computer science quite a bit, and it's a different type of variable oftentimes. And so really it relates a lot to words and to things arranged with letters and stuff like that. So string is kind of a special concept. I just want to touch on it here briefly. So let's read this. A string over x where x is a finite set, is a finite sequence of elements from x. The word string is used for variables in computer programming languages. So here's an example. Let's let x be the letters A, B, and C. So let beta 1, beta sub 1 equal B, beta sub 2 equal A, beta sub 3 equal A, beta sub 4 equals C. Then we obtain a string over x. And the string is written BAAC. Now the word does not make any sense. Doesn't matter. Okay, it's going to be BAAC, and that's a string over x. All right, you can think of many other strings over x. You could think of, well, CAAABAA. Okay, I mean it can be as long or as short as you want it to be. It could be Kaba. Okay, it could be Kaba, right? Like we had here, Kaba or Kaba. I mean, you can do any number of combinations here of these letters, and so as many or as few as you'd like. Since a string is a sequence, order is taken into account. Okay, so these orders do matter. For example, the string BAAC is different from the string CABA. Okay, even though it uses the same letters, notice there's two A's, a B, and a C. Both of them use the same amount, but it's different because the order is different. Okay, so note that order is taken into account. The string with no elements is called the null string. It's denoted with this lambda. Okay, lambda, like a lamb with lamb. Okay, lambda. Now that is called the null string. It's the string of no elements. All right. X star denotes the set of all strings over x. It's kind of like the power set, although we could probably prove this, I guess. It's infinite. It's going to be super large, and x plus denotes the set of all non-null strings over x. Ignore that spell check thing. X plus just denotes, again, the set of all non-null strings over x, okay? Let's give an example. So let's say the set x is just the letters A and B. Some elements of x star would be lambda, which is the null set. Sorry, not the null set. It is the null string correction. It is kind of like a null set, if you will, but for strings. A obviously would be 1. B would be 1. A, B, B to the 10th, which just means 10 B's in a row, followed by 3 A's in a row, followed by BA. Those are just some elements of X star. So you could sit here listing them all day, all right? But X star denotes the set of all strings over X. All right, let's move on. So moving down, and let me, let's do this here. I want to talk about some other examples here. Let's look at this. Let's say X is the set of A and B again. Right here. Some elements of X star are this, which we just talked about, so ignore that. Copy and paste error there, kind of. Or more like, snip tool error, okay? The length of a string alpha, okay, alpha, is the number of elements in alpha. And the length of alpha is denoted with these absolute value symbols, but that means length of alpha, okay? So if we're in the world of strings and you see that, don't think absolute value, think length of this string. It's kind of like cardinality when it's surrounding a set. It means how many elements are in that set. All right, so if alpha is defined to be BBABA, and beta is defined to be B to the 5th, alpha to the 3rd, no, it is A to the 3rd, sorry, B to the 10th, then the length of alpha is 5, and the length of beta is 18. I hope you can count. So 1, 2, 3, 4, 5, there's the length of alpha, 5. Now, when you have exponents, there's 5 B's, 3 A's, and 10 other B's here. The order does matter, but you add them up and it's 18. That's why you have that length there. Okay, so from the example above, if we write alpha beta, that's called a concatenation, okay? It's kind of a cool word of alpha and beta. It's a concatenation of alpha and beta. And what it means is you put alpha first, then beta second. So here, look at this. Boom, alpha, right? And then boom, beta. Nice. So you got that there. Now let's talk about this last one. If gamma, there's gamma. Hey, look at we're learning some Greek here. Is BAA and theta is CABA, then gamma theta is ba kaba, right? You just put them together. Now, if I flip it around, obviously it's kaba ba. All right, so you got that. Now, don't be confused when you get here. It's gamma and then the null string, which just is going to leave us with gamma, which is ba. Or if you do the null string first and then the gamma second, it's going to still just be ba, because the null string is nothing, okay? And so pay attention to those examples. Concatenation, excellent. Way to go on some intro to strings here. You guys have a wonderful day.